Good day. This presentation answers all parts of the need for project management matrix. The case is really about more than measurement. It is about decision courage. The company has talented people, but talent without early warning information allowed expensive R&D projects to live too long. The central argument is that metrics must help leaders learn, decide, and redirect resources before failure becomes costly. The next slides answer Part A questions about R&D failure, finger pointing, Figure 1, overthinking, project success rates, the PMO's role, early termination, blame, engineering realism, the root cause, and whether the PMO should lead metric development. Question 1. Can the failure of R&D actually be this devastating to a company? Yes, R&D failure can damage revenue, cash flow, market confidence, and long-term competitive position. R&D failure can be devastating because innovation feeds future revenue. In this case, the company faced stock decline, a downgrade, dividend cuts, and weak new product performance. Question 2. When project work goes bad and failures occur, is it common practice for finger pointing and the laying of blame to occur even at executive levels? Finger pointing is common when governance is weak and performance information is incomplete. The PMO becomes the easy target. Question 3. What information is found in Figure 1? Figure 1 shows where 7 failures were identified across the life cycle. Its value is the pattern of late recognition. The figure is useful because it shows the life cycle in which the failure was identified. Question 4. What information is lacking in Figure 1? It does not show why decisions came so late. It lacks the deeper data leaders needed: root causes, changing assumptions, value signals, decision thresholds, and spend at risk by phase. That missing information is why better matrix matter. Question 5. Is it possible that highly talented resources can overthink an R&D project to the point where they look for the most complicated solution rather than the simplest solution? Talented people can still drift. Sometimes expertise pushes a team toward elegant technical solutions when the business only needs a workable one. Question 6. Is it good or bad to have 5 R&D projects out of 12 completed successfully? 5 successful R&D projects out of 12 is not automatically bad in a high-risk innovation environment, but it becomes troubling when the failures consume large amounts of money and the successes do not produce strong revenue. Question 7. Can a PMO prevent failure? A PMO cannot prevent all failure. It can reduce avoidable failure through standards, dashboards, lessons learned, and governance. Question 8. Is it inherently dangerous to encourage a project manager to recommend that his or her project be terminated during early life cycle phases? Its value is in creating transparency, comparability, and learning so leaders can act early. Question 9. Who, if anyone, should be blamed for the failure of the projects in this case study? The case study should not be reduced to the engineers failed or the PMO failed. The blame is shared. The executives endorsed the project portfolio. Engineering controlled most project managers. The PMO provided status reporting, but not enough early warning intelligence. Question 10. Is Anne Hawthorne's description of engineers realistic? Anne's description of engineers is partly realistic because technical optimism can keep R&D alive too long, but it is also too broad. The real issue is not simply engineers. It is weak decision visibility. Question 11. Would you agree with Al Gray that the real cause of the failures appears to be a lack of good metrics? If this is the cause, then how do you justify that other projects were successful? Al Gray was right that metrics are central, but metrics only work when leaders are willing to use bad news early. Question 12. Should the PMO take the lead in establishing the metrics? The PMO should lead metric development, but not alone. It needs cross-functional participation and executive sponsorship. Question 13. Are a few days enough time for the follow-on meeting, and should executives attend? A few days is enough for a first framework meeting, not a finished metric system. Executives should attend because their support and decision authority are essential. The next slides answer Part B questions about the relationship between best practices and new metrics, whether the metric team is properly composed, whether senior management should be included, whether metrics can feel like surveillance, whether John's 4 questions are correct, and which metrics fit innovation projects. Question 1. Is there a relationship between capturing best practices and developing new metrics? Yes, best practices should feed metric development because lessons learned show what should be measured early next time. Question 2. Is the makeup of the team correct? The team is mostly correct because it includes the PMO, marketing, business development, engineering, R&D, and manufacturing. That covers the main work stream. Should someone from senior management also be part of the team? Senior management should be represented, so the effort has authority, funding, and fast decision support. Finance, customer-facing sales, and data IT support would also strengthen the team. Question 3. Does it seem reasonable that some people might feel metrics can be a spying machine? Yes, some people will see metrics as surveillance if the measures are tied to punishment. The message has to be clear. Metrics are for learning, risk prevention, and better resource decisions, not spying. Question 4. Are the 4 questions posed by John correct? John's 4 questions are correct. What metrics to select, how they will be measured, how they will be reported, and how management will react. But they are incomplete. The team should also ask why each metric matters, who owns the data, and what action is triggered when a threshold is crossed. Question 5. What metrics would you include in the list that may be appropriate for innovation projects? Innovation metrics should include technical feasibility, assumption stability, risk trend, customer validation, value contribution, capacity impact, schedule cost performance, resource readiness, and best practice use. The best metrics do not just look backwards. They behave like early warning signals while leaders still have options. The next slides answer Part C questions about the risk of reporting too many metrics, the risk of reporting too few metrics, and how Exhibit 1 metrics can be categorized using the metric categories in Table 1. Question 1. What are the risks of reporting on too many metrics? Too many metrics create noise. People spend time measuring instead of managing. Executives struggle to see what is critical, and teams may begin reporting numbers without learning from them. Question 2. What are the risks of reporting on too few metrics? Too few metrics create the opposite danger. Leaders may overreact to one bad number or miss important warning signs entirely. The balance is not more or less for its own sake. The balance is decision usefulness. Metrics should be few enough to understand and broad enough to prevent blind spots. Question 3. Using Table 1, categorize the metrics of Exhibit 1. This slide begins the categorization of Exhibit 1 metrics. The categories are not perfect boxes because some metrics serve more than one purpose. For example, percentage of work packages on schedule is a milestone metric, but it is also directional because it shows whether schedule performance is improving or weakening. Customer satisfaction is an end result metric because it reflects perceived value. The point is to categorize metrics by how they support decisions, not just by what they count. This slide continues the categorization. These metrics focus on assumptions, revisions, constraints, risk concentration, and economic return. For innovation projects, assumption stability is especially important because the early project plan is often built on incomplete knowledge. If critical assumptions keep changing, then the baseline should not be treated as dependable. These measures help leadership see whether the business case is becoming stronger or weaker. The next slides answer Part D questions about how to distinguish a metric from a KPI, what determines how many KPIs should be reported, and how to apply KPI selection criteria to the metrics list. Question 1. Is there a simple way to differentiate between a metric and a KPI? A metric measures something. A KPI measures something that is directly tied to performance, a target, and a decision. All KPIs are metrics, but not every metric deserves executive attention. Question 2. What factors determine how many KPIs should be reported? The number of KPIs depends on project phase, complexity, risk level, stakeholder needs, reporting burden, automation, and whether the information will actually trigger action. The better approach is a small executive KPI set with drill down metrics available when the project turns amber or red. Question 3. Using the KPI selection criteria in Exhibit 1, complete Table 1. This slide applies the KPI criteria: predictive, measurable, actionable, relevant, automated, and few in number. Question 4. How many of the metrics in Table 1 are now considered KPIs? Metrics such as work packages on schedule, work packages on budget, baseline completion, customer satisfaction, changed assumptions, and critical risk concentration can serve as KPIs because they help leaders decide whether to continue, intervene, or investigate. Resource quality and resource assignment are still important, but they may fit better as drill down metrics unless they become a central driver of project risk. This slide continues the KPI selection. Cost revisions, schedule revisions, net operating margin, SV, CV, SPI, and CPI can be KPIs because they are measurable, actionable, and tied to controlled decisions. Unstaffed hours, personnel turnover, and scope change meetings may be conditional or drill down KPIs depending on the project. In this model, roughly 11 metrics should be treated as executive KPIs, while others should stay available for deeper diagnosis. The count matters less than the discipline. Each KPI should support a decision. The next slides answer part E questions about whether any KPI can be measured, whether the boundary box approach satisfies the need for KPI targets, and what reasonable boundary boxes could look like. Question 1. Can any KPI be measured? Yes, any KPI can be measured if the organization accepts that not every measurement will be perfect at first. Some measures will be direct and quantitative. Others will use ratings, estimates, or proxy data. That is still better than ignoring what is difficult to measure. Question 2. Does Exhibit 1 satisfy the necessity for a target for a KPI? Exhibit 1, the boundary box, satisfies the need for a target because it gives leaders a frame for interpreting results. Superior, good, standard, caution, and risk of failure. Still, a boundary box only becomes useful when it includes data ownership, reporting timing, escalation rules, and agreed responses. Question 3. For each KPI identified in the previous case, establish a reasonable boundary box. This slide gives sample boundary boxes for schedule, cost, baseline completion, and customer satisfaction. These ranges should not be treated as universal rules. They must be tailored to the project's risk level and life cycle phase. For example, innovation projects may tolerate wider cost or schedule swings early, but customer rejection or safety failure may require tighter thresholds. The sponsor and project manager should agree on these boundaries at the beginning before bad news appears. The next slides answer part F questions about value matrix, what makes them subjective, who should influence value components, whether value components can change, when a project should be canceled, and when a low value project might still continue. Question 1. What factors would make this value metric process more subjective than objective? Value measurements is subjective because customer value is partly perception. Quality, safety, features, cost, and timing do not matter equally to every customer or every project. Weighting factors are also judgment calls, especially early in the life cycle when data is incomplete. Sponsors may unconsciously weight criteria to protect projects they already favor. The process becomes more objective when assumptions are documented, customers are consulted, scoring rules are defined, and weights are reviewed at gates. Question 2. If these innovation projects were for external rather than internal clients, who should have more of an influence in the selection of the value components, the customer or the contractor doing the work? For external clients, customers should have the strongest influence over customer-facing value components because they define purchase value, but the contractor should still influence feasibility, cost, safety, technical trade-offs, and schedule realism. The best approach is joint definition. Customer voice sets value priorities, and contractor insight tests whether those priorities can be delivered responsibly. For internal projects, the sponsor and affected user should define value, not only the project team. Question 3. Can the value components change over the life cycle phase? If so, under what circumstances? Value components can change when customer priorities shift, technical results reveal newer constraints, market conditions move, or safety and regulatory issues emerge. Question 4. At what value contribution level would a project definitely be canceled? Cancellation should be strongly considered when the value contribution is persistently below 1.75, or when a fatal safety, compliance, or technical threshold is crossed. Question 5. Under what conditions would a project continue even if it falls below the acceptable value threshold limit? A project may continue below threshold only with a documented recovery plan, strategic necessity, portfolio dependency, regulatory need, or clear learning option value. A temporary dip is not failure. A downward trend without recovery is the warning. The next slides answer Part G questions about project cancellation, the advantages and disadvantages of each cancellation approach, which approach should be selected, and whether an exit champion should use a different criterion, such as ROI. Question 1. What are the advantages and disadvantages of each cancellation approach? A senior sponsor has authority, access to resources, and strategic visibility, but may resist cancellation because failure reflects on them. A lower or middle management sponsor may see the daily truth sooner, but may lack the authority to stop the work. An exit champion brings independence and can challenge emotional attachment to the project, but may lack execution context and may be viewed as a project killer. No single approach is perfect because cancellation is both a business decision and a human decision. Question 2. Which approach would you pick? I would use a hybrid approach. Project sponsor, independent exit champion, and executive steering committee. The sponsor owns value and resources. The exit champion challenges continuation logic. The steering committee makes the final decision. Question 3. Can the exit champion use a different criterion, such as looking only at return on investment? The exit champion can use ROI, but should not use ROI alone. Innovation projects may have future value, strategic positioning value, customer relationship value, or learning value that short-term ROI does not capture. Still, those arguments must be documented or they become excuses to keep weak projects alive. The next slides answer Part H questions about whether metrics can predict project success and capacity needs, and what risks appear when those predictive metrics are used. Question 1. Can a metric for predicting success be developed? Yes, both can be developed, but they should be treated as estimates, not certainties. A success prediction metric could combine technical readiness, value score, assumption stability, risk burndown, customer validation, and resource readiness. Question 2. Can a metric for predicting capacity needs be developed? A capacity metric could use projected demand multiplied by probability of success, ramp timing, and confidence range. That connects innovation work to manufacturing planning. The metrics should update at each gate because uncertainty decreases as the project matures. Question 3. What are the risks assuming success prediction and capacity metrics can be created? The risks are real. Leaders may treat uncertain forecasts as facts. Teams may inflate success probabilities to protect their projects. The company may overbuild capacity and carry unnecessary costs, or underbuild capacity and disappoint customers. Forecasts can also become stale if assumptions are not refreshed. To manage this, success and capacity metrics should be reviewed by the PMO, manufacturing, finance, sponsors, and portfolio leaders. The numbers must be challenged before major capacity decisions are made. This slide lists the references used for the presentation. This slide continues the list of references used for the presentation.